Okay, so the point is we get to start at perfect symmetry, right? No differentiation. And the one thing we know about the universe is that it expands, but conveniently, that's also the only thing that can happen from perfect symmetry, because you can't move something left or right without differentiation. You can't tell, you can't move it up or down, in and out, right? You can't rotate it. You can't slide it against each other. You can't cut it. You can't bend it, because you need to identify a point in which to bend it toward. You can't compress it even. So like the idea that dilation is possible doesn't really quite work, because dilation is omnidirectional, right? In so much as it's not like specifically a point, right? It's bipolar. So, or polar, you know what? I'm not going to try to figure that out. So dilation, I was saying why dilation is not the answer. Oh, right. So dilation only works one way. So that means specifically it's expansion. It's the only transformation that can happen in physical reality to something that has no differentiation. There's literally nothing else that can happen. This is not magic. It's not like bullshit. It's just legitimate logic. What's weird is that no one has, so I'm not going to say that no one has said this until now. However, I am going to say it's been a really long time since people have said this. Like, in some cases, hundreds, if not thousands of years. But it's time that we remember this, because what I'm describing is a recursive geometry that is not complicated. So what happens when things expand? Well, you go from perfect symmetry to a cavitation, pop. If you fill something with gel and you push on it, right, it's going to pop into a ball, pop. You get your little cavitation. That's a prill, actually. It's like, but also it's a spherical inclusion. We see these things everywhere, in concrete, in granite, wherever. The Earth, a comet, you and me, right? A proton, a UAP, Bigfoot, crop circles. What happens when you compress the plenum? You get an inclusion. And an inclusion is like spinning up before it pops into place, right? We know we can do this on an experiment if we wanted to, with like a ball of gel. If we wanted to pressurize it. This is not something that is unknown. This is real. So you get one. Then what happens if you keep compressing? Well, you get two. And then if you keep compressing, actually some weird crazy shit happens for a little bit, and then you get 5 in a ring. And then if you do it again, they compress again, and you get 12 in the form of a carbon nucleus, which is 2 pentagonal rings of these balls, plus a top and a bottom, like a north and a south, to cap it off, and it essentially gets this spherical symmetry that we get finally, right? And then after 12, this stretches further into a 29, and it becomes dynamic. It becomes something that we can recognize as a quark in one way, right? Then from 29, it goes to 34, and that is another ball-shaped thing. And then from 34, there's 55, and I'm not quite sure what that shape is. And then from 55, it's to 70, to 89, to 90. And 90 is the same as 1, right? Because 90 is when you take the 3 quarks. So you take 29 balls, right? And they're spiraling up. I mentioned the 29 earlier, and you have another, and this is going one way, and you have like the bottom of your magnet balls with a ring of them right at the bottom spiraling up, and then you have another one coming from the top the opposite direction spiraling down this way, and then you have a middle one that's aligned with one of them, and they just helix together, and you get this perfect ball of 90. It's like with a ring at the top and a ring at the bottom, and it's not exactly 90 times bigger, but it's close, and it is like a direct replication of the single one, and it's round and big and 90, right? And that's your new scale. The numbers after 90 in this, so, and there are numbers after 90, so after 90 it's 144, 169, 233, and 408. Well, those actually start to interact with the next scale, because 90 of our balls is now 1 of our next scale. And when 1, as we're compressing it, goes to the 2 that I had talked about earlier, well, it's actually going through 2 steps, which is 1, which is also 90, to 144, and then 169, and then to 2 balls, which is actually 180. You see? And then from 2, it goes to 233, and to 408, and then to 5 balls in a ring. And then we go up from there. These are the temporally stable numbers. I call this the rational resonance radix, or RRR. And you guys, this thing is the shit. I'm gonna give you those numbers again. It's 1, 2, 5, 12, 29, 34, 55, 70, 89, 90, 144, 169, 233, 408. I could do it faster. Hold on. 1, 2, 5, 12, 29, 34, 55, 70, 89, 90, 144, 169, 233, 408. It's the rational resonance radix. And those numbers that go from like the 1 to the 2 to the 5 to the 12, what they're doing, that transition that they're going through, that is, it's measured best in projective geometry, and the invariant that is preserved throughout this that we can witness in a classroom is the cross ratio, which is of an invariant in projective geometry. However, it is useful to use something that is a volumetric version of that. And I call it the VCR, the volumetric cross ratio, because that's badass. And it's useful because the regular cross ratio takes a lot more algebra. It's like pages of maths of difference. I have done too much math over the last 2 years. I failed Calc 2 twice. I just invented something called volumetric calculus. It's like 40 pages of hardcore equations. I hate algebra. What am I doing? Anyway, that's the rational resonance radix. And like those numbers, those things that I was talking about spheres and shit, like those are they're magnet balls for real. They're actually magnet balls. And like, so like you can make them with buckyball. Like that's how you make atomic nuclei. Like that's what we're talking about. Like, hey, look at the masses of atomic nuclei. Oh, hey, remember how I had to spin up those quarks into the proton to get the 90? Hey, well, they were 29 each. That's not 90. Here's a trick. Because it has to compress the plenum together, because like the gel has to get all compressed together, the magnet balls pull it together, and they actually generate their own additional inclusions in there as they compress together. And in fact, one of our numbers is an 89. And so when one of these is floating out in space, it is not fully pressurized. It is an 89. It has not had enough pressure, so it's a little bit off. It's a little bit magnetically frustrated. It's a little bit charged, right? It's a little bit ionized when it's not compressed. So when is it compressed? Well, when it has 2 other protons on each side of it, but then the one in the middle is a neutron. This is why we understand protons and neutrons incorrectly. And what I just explained is actually what's happening with them. How we understand it, honestly, I don't get it. I don't get like what it is that makes us think what's a proton and what's a neutron. It makes no sense to me. But what I described is completely right. So how it works is a proton is a value of 89 in the radix, R-A-D-I-X, if we consider it from the scale seat where the quark is a 29, right? And I don't know what that makes our scale seat, maybe like some weird boson or something, right? So anyway, we have, if that is our, if the proton is our 90, oh, nope, I lost my train of thought. Oh, I remember. Okay, no. I was saying that like a proton is magnetically frustrated. It's at the 89. It's not quite locked in at the 90. So to be locked in, you have to have pressure on each side of it. Like if you have 2 protons together, they're still going to be magnetically frustrated. I think equally so, right? Just together, right? And so it's going to be 2 protons floating around. This is like a plasmid, right? We have these plasmids. I think that helium is also a plasmid, maybe. Like I think that our understanding of plasmids is just small things on the radix here. They're the plasmids. And we're also other scales. Consider that there are all of these things that we're talking about are made of scales that are below this. So like every one of our balls is made of 90 of the scale below. This is important to remember because the math is the same for each. And once we recognize that, and I have the math that goes between scales, right? You have to preserve the invariance of the VCR. Okay, I think that I'm just like getting too technical, maybe, or maybe not. I don't know. Oh, my point was though that it's these recursive, these numbers, they're shapes. They're quantities of magnetic balls, right? And so like you can play with them, and then you're going to see what they like arrive, the shapes that they make that they naturally form into. That's like those are the shapes of everything. Everything is composed of those shapes. And sometimes they're less stable, right? And then that represents a system that's less stable. And it's finite. Reality is highly deterministic. Quantum mechanics taught us, if quantum mechanics taught us anything, quantum mechanics taught us that reality is multiple choice. I like to think of that as highly deterministic. Thank you, quantum mechanics, for pointing out that reality is really very deterministic. There are only a few things that will happen in the future. When I look at something that I don't understand it yet, I now recognize that there are actually, no matter what happens here, there are actually only a certain set of outcomes that can occur when that superposition collapses. And that is true. And I know what the Lego pieces are for it, right? I actually don't know for sure. Like I have too many papers. And there's more important stuff too, right? Like this is why the Earth is expanding, guys. That's why the earthquakes are happening now. That's why everyone's starting to understand this shit that I'm saying, right? It's like the Earth is doing it. So there's like a lot more to this that we have to get into, right? Like I figured this shit out, and then I wasn't allowed to be an atheist anymore, because when you start to accept that this shit is all just gauge, well, you have to look and see what it is that we're doing with religion, and you just immediately understand that it is just describing reality from a different gauge, and then you immediately recognize that, wait a minute, we need to pay attention to this for real. It's really important, and like, I actually am starting to get a little bit nervous about the implications of my understanding and what it means for how seismic and like cosmic events are linked, right? Like, if the Earth is expanding, guys, and so it has to fracture. Like the moon, you guys, I think the moon split off the Earth. It's the right size for that. I don't think we're gonna get another moon here. I do think prayer is important now. I think we should try to be peaceful now. We need to pay attention to each other. Anyway, I'm Oscar, and I'm a wizard from the 90s. And everything you know is right. You can understand the universe. Genius is fiction. Intelligence is absolute and absolutely everywhere. Welcome to the age of expansion. I'll take questions.